I'm Anil Kumar. Welcome to my series on calculus. In this video, we'll discuss a complete test paper based on Introduction to Derivatives. We'll begin with the basic concepts of finding tangent equation to development of derivatives from the functions. So here are 10 questions for you. First four are being displayed on the screen. Have a good look at them. You can pause the video, copy these questions, work them out. Question number 5, 6, and 7 will go one by one. Here is actually question number 5, where you need to sketch the graph of the function. Then we have question number 6, where you need to find the derivative using first principle. Question number 7 is to find derivative at a point. Question number 8 is a velocity displacement function. Then we have to find equation of a tangent line for a function at a point. And question number 10 is to find points where the tangent line has the same slope as the given line. So these are the 10 questions which we are going to answer one by one. You can actually pause the video, answer these questions, and then look into my solutions. Let's begin with the very first one, which is find a general expression for slope of tangent line at the point pxy on a semicircle with radius of 1 centimeter. Now, this is an excellent question, which I think is probably the toughest question also. So you can try answering this. Here is how I'm going to approach to this. Let's sketch and understand the scenario. We have a semicircle here. So let me draw a semicircle. Semicircle will be something like this. We're saying any point we need to find equation of a tangent line. So let's say that's the tangent for this semicircle, and the point here is given to us as pxy. You need to find equation of this tangent line, right? That is what you need to find. So this is your tangent line, which is under consideration, and that's the point. How are you going to find it? I think the concept is clear to you now. With this concept in mind, you can actually pause the video and answer this particular question. The idea of solutions is to review the concepts learned, and that should help you in your own test paper. So these are test paper questions. Okay, so let's begin by saying that the equation of the tangent line means we need to find the slope first thing. So since it is tangent, if I connect this to, let's say, center, if I connect this to center, then the tangent and this radius OP will be at right angles. That is the concept. So the concept here is that the tangent and radius, we can say radius, is at right angles. That is the concept. So without using derivatives, we actually find the solution of this. So what is the point on this particular semicircle? The equation of semicircle is x square plus y square equals to 1. And you could always isolate y from here. So you get y square equals to 1 minus x square. And y is equal to square root of 1 minus x square. Now we are going to take only positive values, right? Here, you know y is greater than equal to 0. Then it becomes a semicircle. So that is the y value, and therefore any point here will be x value, and the y value is going to be 1 minus x squared square root. Perfect. Now, you know this point x and y values, and you can find slope of OP. So let me write down what is slope of OP now. So slope of O to P is basically y value. If I drop this perpendicular, in that case this is x and that is y, correct? So the slope of OP is y over x, which for us is equal to square root of 1 minus x squared, this is the y value, over x. And slope of the tangent, let's call it m of t, will be negative reciprocal, which is negative of slope of the radius at this point. So we will write this as x over square root of 1 minus x squared. Does it make sense to you? So that becomes the slope. And once you know the slope of this particular tangent, you can find the equation also, right? So it says find general expression for the slope of tangent line. So the general expression for slope, which is, we are writing this as m of t, is equal to the x value over square root of 1 minus x squared. Does it make sense to you? So that is how we are going to get this particular solution. Now here we have not adopted any derivatives, no calculus involved at this stage. But that gives you an idea how we had been working with the tangent so far. It was well defined for a circle, right? And that is clearly the definition which we know. But when we focus on the curves, this definition fails, and that is where we come to the derivatives. So question number 2 is basically on derivatives. It says derivative of a function is a point, a secant, a tangent, or a function. Well, think about it. What is it? So sometimes it looks like a point, sometimes a value, sometimes a tangent, a secant. Well, what it is? Let's try to uh, focus on this. So derivative, let's take an example once again. So I'll draw. It'll be easy to understand if you draw something. So let's draw, this time a parabola. Okay, so we draw a parabola here. Right. These freehand sketches are there for you to understand the concept. They are not very accurate, but they are good enough for any test paper. Okay, where we are saying sketch. Now we are not saying graph. When we say graph accurately, that is a different story. You have to be more careful about it. Okay. Now, so let us say this is on coordinate plane, origin x and y axis, and we have y equals to x squared. Simple. Now, if I find tangent at this point, so on the graph we'll find tangent, slope at points, different points, right? Then what happens? So if I find tangent at this particular point, I get a tangent line, and clearly the slope here is 0, so that point we get here. And if I find a tangent at some other points, if you do it, then that's the tangent, which is some positive value. So so at this point we have a positive value, and we see that it is increasing, right? Similarly on this side also it is negative though, but negatively increasing, or you can say decreasing. So if I have to draw a graph of this, then what we really get is a straight line, and the straight line will be like this. So if you do this exercise, what you get is this straight line, which is y equals to 2x. Right. So this is the first graph. Let's take another function. Okay, this time I'll draw a function slightly above. Okay. Let's take a cubic function. We'll keep things simple. Let's take a cubic function, and we see that at origin the slope is 0 once again, and that becomes the slope. However, it is always positive in this part, and here also it is positive. What we see here is that the slope is always positive, right? So we notice that slope is always positive. And if you sketch a graph using the points at different places, what you get as a graph is a parabola, right? The equation of this parabola will be y equals to 3x squared. Now, what do you notice here? What is the derivative? So I did all this just to explain you what should it be, the derivative. Now, can you answer the question? The idea here is to understand the concepts. So what you got here is the value y equals to 2x, y equals to 3x squared. What do they represent? Clearly, they represent a function. So derivative is a function, right? So what is the derivative? Let's keep it very simple and clear. And clearly, what we have got from here is that the the derivative. So clearly what we've got is that the derivative is a function. Is that clear? Normally you're finding the value at a point or equation of a tangent at a point. Well, that is at a point. But in general, whatever you get is a function. So treat derivative as a function. It is not a point. It is not a tangent or a secant. Perfect. So that is something which is very important to understand. And so I took my time to explain the concept as we are also solving the questions. Now, question number 3 here. Now, let us take the solution for question number 3. If limit h approaches 0 for f of 3 plus h minus f of 3 over h equals to 6, what does it indicate about the graph of the function f of x equals to x squared? So let's rewrite this limit. It is limit h approaches 0 for f of 3 plus h minus f of 3 over h, and this limit is given to us as equal to 0. We're also given the function f of x as equal to x squared. So what does it indicate on the function clearly? That is your question, right? So let's try to understand the scenario here. So I'll sketch to represent the scenario. Uh, so let me make a parabola which is kind of wide. So it is wider than what it should be, just to emphasize on what we need to figure out. So let's say we have a parabola which is kind of like this. Okay. But this is the graph for the function f of x equals to x squared. Is that clear to you? Okay. So let us find these 2 points and then difference in this. Okay. So what I'm going to do here is indicate the 2 points. Let's say this is f of 3. So this point I'm saying is at 3. And somewhere there we have a point which is 3 plus h. Is that clear to you? Now, when we say f of 3, we mean to say this point, right? So here, the y values, that is f of 3 plus h, and this is f of 3. Now, the expression which is given to us is f of 3 plus h minus f of 3. That means you are looking into what? We are looking into this portion, which is minus f of, so let me write down this as f of 3 plus h minus f of 3. Is that clear to you? And this is h. This portion here is h. Is that clear? So what we have got here is that this portion here is the numerator, right? And this portion here is the denominator. So now we understand that part. Now this part is called difference quotient, right? So you have on the numerator, it is kind of rise you have. And on the denominator, you have run. And you're saying limit h approaches 0. That means that this point is coming very close. This point is coming close to this point. These two are not that far as it looks like, but they're very, very close. I've kind of expanded that particular portion, let's say 1,000 times. So this point is practically very close to this. So this actually gives you what? That is the question. So I hope now you have understood what the question is. Perfect. And now let us write down our solution. So basically, the question is telling you that if you are looking into limit of f of 3 plus h minus f of 3 over h, then it is basically this. So it's a secant line which goes through these 2 points. Perfect. And since h is approaching 0, means it is coming very, very close, it is representative of a gradient. You can also call this as a tangent, or you could also call this as derivative. And all this is at x equals to 3 on f of x equals to x squared. Perfect. That is what it is trying to say. So I hope the concept is absolutely clear. So I took this time to make you understand this concept that could be represented as a gradient at f of 3. It could be a tangent at x equals to 3 on the function x f of x equals to x squared, or it could be derivative f dash 3. So it could be any of these three things, and the value given to us is 6. So now you know what this is. This basically is the derivative of the function at 3, and this value is 6. That is what it is. Perfect. So I hope that makes things absolutely clear. Now let's get to another question which is related and which is also seen in the test papers. The question here is the expression limit h approaches 0 of 2 plus h whole cube minus 8 over h represents derivative of a function f at a point pxy. Find the function and the point in the given context. So this time we are already given what this is. We are saying limit h approaches 0 for 2 plus h whole cube minus 8 over h represents derivative of function is derivative of f at a point P which is xy. Perfect. So this is exact solution of question number 3 where the function is x squared. Now, question number 4 is you need to find the function and the point. Earlier, we were given the function which was x squared and the point was p equals to 3 and 3 squared is 9. Do you see the correlation between the two? So that is how they are related. And what we are looking at is a difference quotient, which is commonly used to find the derivative. And we'll name this as d dx or f dash x as we move along. So we are saying at this stage that this expression represents a derivative. We are saying this is d dx of a function f of x. That is what we are saying. So the expression which we call as difference quotient represents a derivative of a function f at a point pxy. Find the function and the point in the given context. So can you name the function and the point? Well, The first part, let's look into a general expression and then you can correlate. General expression is limit h approaches 0 of f of a plus h minus f of a over h. Now that is general expression. And this is general expression of dy dx or dfx, right? So in short, I'm writing dy dx. I should have written f dash x, right? So we could also write f dash x. So anyway, let me change this to f dash x, the derivative. Since we are using, yeah, that is okay. So that is the derivative. Now, can you correlate? Clearly from here, you know we're talking about the function f of x, which is equal to x cube, right? This here represents x cube. And the point here is f of a. So f of a is 8, right? So we know f of a is 8. So which is x cube equals to 8. And that gives you x equals to cube root of 8, which is 2, right? And therefore, we know that the point here is 2, 8. Is that clear to you? So we have our answer, and the answer here is that the function f of x is equal to x cubed and the point is 2, 8. Perfect. Let's move on and see how to sketch a graph now. So we have understood what is the derivative. Derivative is a function and it represents at any point slope, gradient, right? Tangent slope. That's what it represents. And now the question before us is the graph of the function is given, is sketch the graph of the derivative. So f dash x is the derivative. So we have to sketch graph of derivative, right? Now, it is important to understand that derivative is not defined at corners. So let me write down. Derivative does not exist at corners since you're never sure of what that slope could be, right? So it is not defined here. Now, the other part, we have got basically three parts to this, and these are straight lines. And so it should be easy to find the derivative. So in the first part, which is, let me show some work here. So in this part, we have derivative which is positive and you can find the slope of this. So slope here is 1 by 1 and therefore I could write this as slope m equals to 1. On the other two parts, it is kind of, here also it is 1, right? This is also 1. So in this region it is 1. And if you go beyond this, that means in this region, it is minus 1. So let's say, let me write slope here. So slope in different regions, this is plus 1 and this is again minus 1. So now I can actually sketch the graph. So we know for sure that it is not defined here. And up to this point, it is 1. And from here, which it is not defined, up to this point, it is -1, right? So that is how we could actually sketch the graph of this particular function. So this is again a end of it. You cannot approach it from the other side, and therefore what you get is yeah. So what you get here is, so what you see is a step kind of a derivative. So let me clearly show it on a bigger picture. So when you sketch this graph, it will kind of look like this. So we have the positive 1 and then we have -1. It is not defined at the two corners where you see the line as a vertex. Perfect. So, so the derivative is here. So you can say this is your derivative of this particular function. So shown there, this is minus 1, that is plus 1, and this is your minus 3, and that is plus 3. So that is how you're going to sketch the function. So it is of slope minus 1 and 1 in the given intervals as shown. Perfect. Let's move on and take the next question, which is question number 6. Find derivative of the function f of x equals to x squared times x minus 1 from the first principle. Extremely important question. Most of the time you don't see the factored form. So I'll actually rewrite this function as equal to x cubed. Let me write first the function itself and then we'll expand it. Okay. So it's better to see it as x cubed minus x squared. And now we can use first principle easily to find the function. So in this particular case, what is f of x plus h equals to? So if I write x plus h, I get x plus h whole cube minus x plus h whole square. And that gives you, let's expand these terms. And what we get here is x cubed plus 3 x square h plus 3 x h square plus h cubed, and then we have minus x square plus 2 x h plus h square, right? And f of x is already given to us. When we say derivative, that means we'll apply the difference quotient, which is f of x plus h minus f of x over h. And that is, we'll write all this, whatever we have here, which is x cubed plus 3 x square h plus 3 x h square plus h cubed minus x squared minus 2xh minus h squared. And now f of x in the minus terms, so we get minus x cubed, and that becomes, we'll write plus x squared over h. Now we need to cancel the terms which are there. So x cube will cancel with x cube and x square will also cancel. So there you go. Perfect. And we forgot to write, which is very important, which is limit h approaches 0. So you have to write limit h approaches 0. Now when h is very small, in that case, you can neglect it, right? So let me rewrite this as limit h approaches 0. And here we get what? We get 3x square h plus 3xh square plus h cube minus 2xh minus h square over h. Now h is common, so we can write this as limit h approaches 0. H is common. And we can actually, before taking that, neglect the values where we have terms like h cube, right? These are very, very small, and h square. So the powers we can neglect, correct? So what we have done here is that h is very, very small as compared to 1, I should say, to 1, and therefore we neglected these terms. So from the other terms, we have taken the common terms, which are h is common. So we got 3x squared and minus 2x. Is that clear to you? Over h. Now we can cancel the h and we get 3x squared minus 2x. So the derivative of the function using the first principle is right there. Correct? So I hope that makes sense. So this h and this h cancel, and you get an expression, which is 3x squared minus 2x. So I hope that is absolutely clear. This is how you can find the derivative using the first principle. Question number 7 here is, if f of x equals to x squared plus 2x, find f dash 3. So, let's find the derivative. We are given the function f of x as equal to x squared plus 2x. So let's find the derivative first. The derivative is 2x plus x. We have used the power rule, right? So that is x to the power of n a times. If that is your function y, in that case y dash is a times n times x to the power of n minus 1. So that is what we've done. Now to find the value at 3, we'll just substitute 3 for x. So we get 2 times 3 plus 3, which is 6 plus 3, which is equal to 9. So we know that the derivative at 3 is 9. Is that clear? So that becomes our answer for the given question. Let's move on and take the next question. Question number 8. The position function of a particle moving along a line is given by f of t as equal to 4t squared minus 20t plus 5, where t is measured in seconds and f of t is measured in meters. Find the time when the velocity of the particle is 28 meters per second. So velocity is what? So in this case, velocity will be the derivative of displacement, and that is given to us as 28 meters per second. We need to find time. So I hope the question is clear. You can pause the video, answer this question, and here is my solution. The derivative is 8t minus 20. So we have again used the power rule. And this is actually the velocity v of t. And we are given this velocity as 28. So we can say 8t minus 20 is equal to 28. So we have 8t equals to 28 plus 20, which is 48. And t is 48 over 8, which is 6. So we get t equals to 6. So in this case, our answer is at t e at t equals to 6 seconds, velocity equals to 28 meters per second. Is that clear to you? So that is how we are going to answer this. Now, second last question here is question number 9, which says, find equation of tangent line to the curve y equals to 2 square root x at x equals to 9. So we're given the function which is y equals to 2 square root of x, and we need to find uh, at x equals to 9. So at x equals to 9, what is y value? We should find this also before we begin all that. So we'll substitute 9 here. So we get 2 times 3, which is 6. So we know the point of our interest is 9, 6. Okay. Now, to find the equation, we need to find the slope first. So let's find the derivative, which is y dash. So some of you may like to write this as x to the power of half, right? And um, let me write the function first as this. And now we'll find the derivative. It becomes easier to understand. So y is equal to half. So you get 2 times half, and you get x to the power of minus half here as the derivative. So that becomes the derivative, which is, you can cancel this out and you can write this as, this is your derivative. So we got the derivative, which is the slope. So we can now find the slope of the function at the given point. So slope m at x equals to 9 is what? Will be 1 over square root of 9, which is 1 over 3. And the equation of line will be y minus y1 equals to m times x minus x1. Now this is the equation of line. So we can now write down y minus y1 is given to us as 6, and slope is 1 over 3, x minus x1, which is 9. Cross multiply, so we get 3 times y minus x equals to x minus 9. And now you can simplify and get the equation of the line itself. So we have 3y minus 18 equals to x minus 9. Bring all the terms together. So bringing them to the right side, minus 9 plus 18 equals to 0. So we get x minus 3y, and that is plus 9 equals to 0. So that becomes the equation of the lines, right? So our answer here is x minus 3y plus 9 equals to 0 is tangent line equation at x equals to 9. Is that clear to you? So that is how you're going to answer this question. So go through these steps, very important question from test point of view. And now let's take the last question, which is question number 10. At what points on the hyperbola xy equals to 36 is the tangent line parallel to the line 4x plus y equals to 1? So we're saying parallel to. What does that mean? So parallel to 4x plus y equals to 1. Let's rearrange. We get y equals to minus 4x plus 1. So the slope is equals to minus 4. Is that clear to you? That is what it means. The second part is the parabola itself, which is xy equals to 36. So what is y equals to? Y is 36 over x. So that becomes uh, the value. Now, we're saying at what points on this parabola is the tangent line parallel to this. So we need to figure out the points. So we'll find the derivative of the function. So let's rewrite the function as such, and then we'll find the derivative. So we have y equals to 36 over x. So we have y dash, the derivative will be, so minus 1 square, right? So it becomes minus of 36 over x square. Now, some of you may like to write this as 36 x to the power of minus 1 and then use the power rule. So you get minus 1 and this becomes minus 2. So it comes in the denominator. Do you see the connection? Correct? So you could write directly also. So that becomes the slope. And now we are saying it is parallel, right? So parallel means this slope should be equal to minus 4. So let's equate this. So we got minus 36 over x squared equals to minus 4, or we can say 36 over 4 minus minus cancel equals to x squared. Well, this is 9, correct? So from here we do get a point, and that is clearly x equals to plus minus. Don't forget plus and minus. Both. There are two answers to this, right? So 2x values. Perfect. Now if x is plus or minus, we'll get two different y values. So y is equals to 3x over plus minus 3, and that is, when you divide this, you get plus minus 12. And therefore we have 2 points. Let's say point A is when x is 3, in that case y is 12, and the other point B will be minus 3 minus 12. So those are the 2 points. Is that clear to you? So I've seen in test papers sometimes students will miss one of the points by ignoring the positive part of it. So square root, uh, always when you are getting back to, is plus and minus. So this is kind of important step which is sometimes ignored, and then you will not get the second part of the solution. Remember, the question says at what points, and that does give you a hint that you're looking for probably 2 points, right? More than one. So I hope that makes sense. With that, we come to an end of this interesting test paper where we learned the strategies to understand what derivative is and solve related questions. We'll take up another higher level test on the introduction to derivatives where we'll use more of the rules, not just the rule on power rule, but more other rules like the quotient and the product rule. I hope that makes sense. With that, thanks for your time and all the best.